Okay, nasaan yung para walang gift? And then, detach natin yung chat box. And let's go live. And yeah, let's increase the volume to 250. There we go. Okay, check lang muna. Exacto, so I can at least have 1 hour and 15 minutes stream. And hopefully, I have 1 to 44 subscriber na sa UIT. Interesting. Never thought that people will subscribe on my channel. I mean, never thought people will subscribe on my channel. Yeah, but anyways, I'll just keep focused on what I wanted to do instead of gaining subscribers. Focus on what I wanted, which is to learn. So that it feels more genuine. Let's see in my TikTok. Okay, I think it's okay now. Alright, so okay, let's go. Maybe I need to reorganize my layout. What if... Oh no, wala akong webcam. What's up, LLM degrader? Good morning. Okay. Yep, actually, it's more of a challenge to me. So since the book is giving Python examples and uses a lot of libraries, I thought that I think I wanted to do it in Rust. So to add more challenge, and I think it's kind of paying off because I was able to understand more. So yeah, though my progress is a bit is kind of slower since I did it in Rust and I'm doing the libraries from scratch. But it's actually it's kind of fun also, but at the same time it's kind of fun because I'm somehow learning a lot of new things. Actually, currently I'm still in chapter 2, Byte Pair Encoding. I'm kinda ChatGPT kinda put me in a position that I need to deep dive on it. I haven't tried ND array, so I'm currently implementing my own Byte Pair Encoding by following ChatGPT. ChatGPT prepared topics. So what I'm doing right now is, oh no, my Droid cam is not working. I send the pages to ChatGPT and then I let ChatGPT to somehow create some topics, more topics. So it's somehow a book plus ChatGPT study. So yeah, I haven't used NDRA. Probably in the future topics. Okay, let's see. I already implemented some of the parts here of the special tokens. Yeah, it's kind of yeah. That's the challenge also that I wanted to have. It's not kind of efficient for actually, though somehow I'm getting interested the more I know the underlying things that's happening on in the LLM. So it's making more interested to learn more. Yeah, sure. Glad to know that there's someone also trying to do this in Rust, because there's a really that not that much people using Rust in LLM. All right, so yes, you already partially started topic 6 because you added boss, EOS, and pad. If your vocabulary, no, the alarm. I need to set the alarm at 8:45 a.m. Then after that, 15 minutes break, and then go to work. Now we formalize what we actually mean, and they when they are used. Special token. These are reserved symbols, control tokens used by transformers. They are not normal language tokens. I think I need to put some comments here so that it's easy for me to uh, recognize the use of it. Okay, beginning of sequence. Then this one is unknown. Token fallback. End of sequence. Padding token. Important insight. Special tokens help transformer understand the sequence structure, not language semantics directly. Example, suppose runtime tokens are played. You may transform them into BOS, player, played, EOS before token conversion. Okay. So BOS exists. It does the transformer sequence starts here. And then, okay. Okay. Mhm. Player, played. Runtime token are played and played. You may transform them into, okay. Why BOS exists? It does a transformer. Very important during auto-regressive generation decoder only transformers instruction formatting. Why EOS exists? It does transformer sequence ends here. Without it, model may continue generating forever. Sequence boundaries unclear. But this becomes very important for batching. Layer played, playing, sentence B. Transformers prefer rectangular tensors. I see. It's just too much. Of course, I think if we load it on the GPU, much better is we have fixed length and fixed columns and fixed rows. Number of, anyways, fixed number of columns. So meaning, if it's displaying, there should be another value here. So pad is the placeholder. Or I mean the fallback for this. Now tensor shape becomes valid. So I forgot the this one is 2 tensor 2. I forgot the the terms for type of BNT. Anyways, probably I'll know it later. So very important future insight: attention mask, causal masking, but I have no idea what are this. Special, all depends heavily on special tokens. The post runtimes token are, what should the token sequence like adding BOS? Runtime token, so I'm going to put it on a runtime token. So in my vocabulary, I'm not going to add it on my vocabulary, but runtime encoding. So most likely here in my tokens, it's already pre-populated. And then since this one is probably tokens that insert, no, not insert, that just push. Now self. Oh, okay. In runtime encoding, I also need to have the reserve token similar to vocabulary. Okay. Wait, so here, actually, I'm not sure if I still need the vocabulary here. Yeah, it seems that I don't need the vocabulary anymore. Is it? Oh no, I think I need to refactor this. I'm getting confused now. I need to refactor it and then put them on their separate files so that it's more of focused on the struct and it's easy to search. All right, self-reserve tokens. Reserve tokens that own. Now we can now put this one here, self reserve tokens that BOS, and then we need the 0. Need to clone it. And then after EOS, all right, so we have here player played. So we have this one. Let's solve that reserve tokens. Now we have it here. Runtime result input. I think let's just new line it here, and then tokens. So input and then runtime result. Power up print for debugging. So this is my runtime. Oh, I'm already printing it na pala. Input, then tokens. What should token sequence look like after adding? This is my example. Important observation: your tokenizer successfully compressed known patterns, played, player played, preserve unknown parts, Exactly sa subword tokenizer have generalization. Next phase. Now this sequence is example conceptually. Now this sequence becomes token IDs. Okay, we need to convert this one to token IDs. So it becomes something like this one. I think let's remove it. So I think I'll just rerun this one and give the result to ChatGPT. So this is my merge rules. FNU often would not become unknown. Byte level token would preserve them directly. That becomes your next major tokenizer. Which is where tokenizer engineering starts becoming production grade. Byte level BP. Okay. Actually, I'm not expecting this one. This is going to be fast. So I'm already on byte level BPE. But before that, I need to separate now. Runtime, BPE runtime. I need to separate now the structs because I'm getting confused now. Use BPE creates BPE runtime. Huh? Either I have an error here. Anyways. I think hindi siya reserved tokens, no? Special tokens. Yeah, it should be called special tokens. I somehow messed up everything. How on earth I can't import them? Yeah. Okay. Alright, this is good now. And then okay. I think I need to rename this one. It's violating Rust ergonomics. Then this one, I need to put them in types. Now training. Oops. PPE training.rs. PPE base. then seems like itong BPE result is only used in BPE training. So might as well rename it to BPE training result. What the? Vocabulary. Vocabulary. It's somehow not that many. Alright, let's fix it one by one. P3 map. Then vocabulary. Serve tokens. BPE training, virtuals. And then I think this one should be replaced special tokens. Special tokens. Now, let's rename this one to clear. Kasi ito. Runtime. Yes, because of this one. And I think itong BPE base, itong sa training, this one should be training result. Initial tokens. Right. There you go. Alright, so ano meron dito? Di ba natin siya ginagamit? I'm going to are never used. Okay. So meaning here, galing talaga ng linter ng Rust. It's making my code much cleaner. I mean efficient, not cleaner, because let's move to the next topic. Topic 7. Oh, nice. Only 5 topics to go. But I think when I go, I'm not sure. I have a feeling that topic 7 until topic 11 is going to be more complex and much harder. Because this one, tokenizer efficiency, so meaning I need to optimize it, and then vocabulary freezing and versioning, domain specific tokenizer embedding relationship. It looks like they are somehow very complex topics. This is one of the most important tokenizer concepts in modern LLM. Your current tokenizer is character level BP because your initial symbols are characters. Example play, yeah. After this is true. Problem with character level BPE, character based tokenizer struggles with Unicode, emojis, mixed languages, malformed text. I think this one actually really makes sense. This one, emojis and mixed languages. Malformed text, binary like text, internet scale robustness. Ano ba? Suppose runtime input contains fire or Chinese characters or something like this. Character handling becomes inconsistent, encoding dependent, difficult across languages. Byte level BPE solution, instead of starting from characters, tokenizer starts from raw bytes. Oh, okay. So it becomes something like this, no? Interesting. So I'll just flip this. Instead of characters, I'm going to convert this one to hexadecimals. I think it's much easier for me to compare if it's going to be like this. And it's easy to load it to the GPU for sure. Because I don't need to encode convert it to hexadecimal. Oh yeah, it's because there's already a so P, because it's like the token ID already, the token IDs. if I'm understanding correctly. Initial symbols becomes or conceptual byte symbols. Then BPE training counts byte pairs merged by sequence, build byte subword vocabulary. Okay. So mawala ng special tokens or unknown. Wait, I don't understand this one. We can spend this slightly reduces. Example, suppose natin, kung tokenizer may fail badly. Byte level tokenizer, UTF-8 bytes, always representable by BPE merged by patterns work important GPT many modern language variants. Because intertext is chaotic, code markdown emojis is important to text characters. BPE. Byte level tokenizer text UTF bytes BPE. So important deep inside, BPE level resolves representation completeness. Meaning, how do I compare this? I mean, the BPE trading because there are some comparison. This is interesting. Mukhang complex tong topic na to. Kasi ito, let's say, compare ko tong play. So, meaning, if it's converted to bytes, it's going like an array of bytes here. Question, what becomes the initial symbol for byte level PPE? Initial symbol? I don't know. So play UTF bytes becomes the initial tokenizer symbol. Huh? For byte level, the initial symbols are the bytes themselves. So play initial, okay, becomes the initial tokenizer conceptually and internally, depending on implementation. Compare your tokenizer, byte level, different initial symbol representation. Medyo it's somehow confusing. Yeah, may pagka-confusing siya. Pero maganda siya eh. Parang mas marireduce yung number of steps for me. But, I mean, yung compatibility nga niya to multiple languages is much easier. Since in bytes na siya. Pero, okay. So, I think, for merge rows, okay, So let's start with the training first. So if we are going to, let's say this one, tapos instead of this one as bytes, so parang ganito siya. Mukhang kailangan ko na maraming time dito. So it will become something like this. Okay, kuha lang ako ng isa pang para i-practice ko lang siya. BLE, byte level encoding, test BLE. Now let's say input. So my input is player. Now what I'm going to do is println muna tayo. Input that as bytes. Ano ba yung pipili ng... Okay, so this is the bytes per player. So if we pull out and hindi na pull out ng ASCII. Okay, let's wait, how do we do this? Okay, since we are going to convert the from characters to bytes, let's start first in the BPE training again. Because the foundation symbol representation changed from characters to bytes, the BPA training pipeline must also start from bytes. That's exactly the correct understanding character. So pair computing. So my next question here is do we still need to split them in white space? And then what happened to the special tokens? Yeah, what happened to this thing? Okay. Kasi I think instead of Okay. So why space is preserved? Because transformers learn word boundaries, formatting, indentation, code layout, sentence structure from spaces too. This is very special, very important for programming languages, markdown, chat formatting. Oh, okay. Interesting. So there will be a drastic change in my BPE training code. Okay. Yeah, I think this is yeah, this is actually true. So GPT style tokenizers. Example, self compression, natural language memory. Important. Modern tokenizers often operate on continuous byte stream, not independent words. That is major conceptual shift. Your learning recommendation for learning person, you may still temporarily shift. I think I'm going to preserve now the preserve now the white space, since that's the somehow the uh, best way. I think I'll go to the path where white space is preserved. How does it work for the merge rules then? So trade is 1 byte. So as UTF-8. So play. What's the input again? Play player. So 1 to 2. Then 32 is then BP pair counting works over the whole string. So yeah, white space becomes a normal sim. This is key shift split pairs. Preserve raw string, then merge. Okay, next convert plain into byte symbols and list adjacent pairs. Wait, how do I is pairing byte per byte? Okay. Initially, byte BP starts with byte by byte. Byte by byte. So not byte per byte. Byte by byte. So alright. So if it's 1 to 2, so 1 2, then how about spaces then? Okay. It's still going to be paired. So dire-diretso nga siya, no? So 1 lang siya. I think I'm going to probably copy this BPE training BPE BLE byte level training. Yeah. Ito ko gagawin. Web mod BPE BL training. Para feeling ko, kaso dito kasi yung pag-create ng pairs is iba na siya. Because these are numbers na din. Kailangan ko na pala mag-out. Mag-end. Minutes. Anyways, I think end na muna ako. Because I need to prepare to work. Right. See you guys on my next stream, which is tonight. I'm kind of excited to continue this tonight. Because, yeah, seems really interesting to convert the BPE training that is using characters instead of bytes. And I think it's more going to be more simple